Question 23, 3 marks. Consider the following equilibrium system. Hexa-aqua cobalt 2 plus aqueous is pink and tetrachlorocobalt 2 minus aqueous is blue. When a solution of these ions and chloride ions is heated, the mixture becomes more blue. Relate the observed color change to the change in KEQ. There are 3 main points that we must consider when answering this question. Point number 1, increase in temperature drives the system to the right hand side. This means that the system is endothermic. Point number 2, as the equilibrium shifts to the right, the mixture becomes more blue. So this particular system has a color indicator. Point number 3, as the reaction favors the right hand side, this means the concentration of the product is greater than the concentration of the reactant. Therefore, KEQ is greater than 1. So let's have a look at the sample answer from the HSC. The mixture becomes more blue as temperature is increased, which suggests that the concentration of COCl42- is increasing. This means that an increase in temperature favors the forward reaction. This response will result in a larger value of KEQ according to the equation. Very simply, the sample answer addresses point number 1, point number 2, and point number 3. Now, I would like to go further than this. If hypothetically this question was more than 3 marks, then we would need to use our understanding of collision theory, Le Chatelier principle, and Q versus K. In the sample answer, it talks about that an increase in temperature favors the forward reaction. That sort of language is consistent with the collision theory. If we use collision theory to describe this phenomenon, we can say the forward reaction rate is greater than the reverse reaction rate. Therefore, there is a net forward reaction. We also know that when the temperature is increasing in the system, the equilibrium shifts to the right-hand side because it is endothermic. And that is the same language as forward reaction given by collision theory. So in terms of the change in KEQ, we can use the KEQ formula. And we know that before K is reached, there is Q. In terms of Q versus K, the condition is Q less than K. Therefore, to re-establish equilibrium, Q must increase to equal K. This means more products must be made and a forward shift will occur. Thank you for watching, and I'll see you next time.